The law of mass conservation. Let's suppose I set up a chemical apparatus and I go ahead and weigh it so I know how much everything weighs beforehand. And let's say it weighs 23.7 kilograms. Okay, and then I decide with my apparatus that I am going to take some crude oil and separate the different components. This is actually an experiment that you might do at college if you take college chemistry. So let's put some oil in there. Okay, let's make it a more oily color. Let's see, how about blue? Alright, so I am going to start a flame and it's going to warm up the oil. Different parts of the oil has different boiling temperatures. So some parts of it come off early and they'll start bubbling and making a gas. That might be kerosene or some other type of real light oil. And some part of it comes off really late. And that'll be the thick, gooey stuff at the end, like motor oil. So, let's watch this come off. It comes up this tube. And usually in this tube, we have a water pipe that goes through these curves. And we turn the water on, and the water runs through here. And it cools down the tubes, which means that these gases now will become liquid, and the liquid will flow down these little curves and start dripping into the beaker. Okay, once this stops, then I can take this, let's say it's my kerosene, and I can pour it off into a different beaker and put it in here, a little dribble, and then I can start over again and turn up the heat a little bit more. So the next thing that comes off might be a little bit heavier petroleum, and it comes up here and again condenses, falls through, and comes out as a liquid. Now I take that one and I pour that one off. And so on until I only have a very tiny bit in here left, kind of a sludge maybe I could call it. And I turn my heater off and I decide to weigh everything again. Well, let's say I weigh the sludge first. And I'm kind of sitting here thinking, well, goodness, I should have told you how much the crude oil weighed in the first place. So let's go ahead and write that number down. Let's say it weighed 10.3 kilograms. Okay, so I weigh the equipment again. And the equipment has maybe a teeny tiny drop of gas up here and maybe a dribble of liquid on the end. I take it away from this pipe, and the water was never really in these pipes, so I don't have to worry about the weight of this pipe up here. And now the equipment weighs 24.6 kilograms. Okay, why did it get bigger? Well, because it still has this little drop of sludge in it. So how much does that sludge weigh? Let's subtract the original weight of the equipment. Let's see, 9. Okay, now remember we are subtracting here, so don't start thinking, oh, I gotta add significant digits because I've got 3 here and 3 here and I should have 3 here. Remember subtraction rules? I just go for the place value, and this number is good because it has one place value. Okay, so that is how much my crude oil weighs. That's left over here. Now, I go and I weigh my first batch that came off, my kerosene. Let's say that it weighed, let's see, 5.7 kilograms. So far I have the equipment that weighed 23.7, and I had put in 10.3. Now, the equipment still weighs the same. The sludge in there, though, weighs 0.9, and then this weighs 5.7. How can I figure out what this one was? Well, the law of mass conservation says that matter doesn't ever spontaneously disappear, or it's not created, it's not destroyed, except by God at the beginning of the world. Everything just rearranges. So if you have weight or mass at the beginning, you're going to have the same amount of mass at the end. Now that mass may have gone out into the atmosphere as gas, or you may have spilled it or something, but it was there, you didn't destroy it. So if we keep a fairly controlled experiment, we can go ahead and add up what we had before, and we can add up what we had after, and we know what all the parts should weigh. So I know I started with this 10.3, and right now I have 0.9 and 5.7. So I'm going to add that up. 6.6 kilograms. All I have to do to figure out how much is in my last beaker is to go ahead and subtract it. So let's go ahead and do that. Minus 6.6. And this is 3.7 kilograms. Because everything has to add back and forth. We have to count for every gram, every kilogram that was there before. Where is it now? Okay, well, let's do an example like the book has. So a chemist is burning a fire in an experiment. So he collects the wood and he sets it to burning. After the wood burns, he sees that there's a pile of ash, and he's noticed that he's gotten smoke coming off of it. Now, how can he figure out how much of the matter went off in smoke? Well, all he needs to know is how much did his wood weigh beforehand. So let's say 7.5 kilograms. How much did the ash weigh after? 5.2 kilograms. Which meant that this hot gases that's produced in smoke must have been 7.5 minus 5.2 is 2.3 kilograms. Easy.